Hi everyone, welcome to the first lecture of the GCSE Mathematics course. So this is the first section of the total number of sections in this course. So there are 7 sections, as I mentioned in the introduction to the course. So the first section is titled Numbers. Now within this section there are 9 chapters. Okay, so we will begin by exploring chapter 1. The first chapter is titled Type of Numbers. So before we go on to exploring various different types of manipulations and advanced topics, it's very important to understand the fundamentals of mathematics. Okay, so we begin by understanding and familiarizing ourselves with some common terms, I say common words that appear throughout the course. It will appear throughout the course, not just throughout the course. It will also appear in all aspects of mathematics. Okay, so there are some certain words such as, for example, even numbers. So even numbers are numbers that end with 0, 2, 4, 6, or 8. Now it will be a little difficult to do a course involving mathematics without knowing the definition of even number. Okay, so what is the definition of an even number? So all even numbers are divisible by 2. So we can express this or write any even number as 2 times k, where k can be any number. So no matter what number k is, as long as there's a 2 in front of it, that number will always be even. So for example, we have the number 4. So notice the number 4 can be rewritten as 2 times 2. 100 can be written as 2 multiplied by 50, where in this case k is 50, and in the case for 4 the k is 2. Then we have another number which is 12,452,678. This is an even number because the last number is even, and this number can also be written as 2 multiplied by 6,226,339. So any even number up to infinity, okay, can be written in this form, 2k, okay, because all even numbers are divisible by 2. Then we have odd numbers. Odd numbers are numbers that end with the numbers 1, 3, 5, 7, or 9. All odd numbers are one more than an even number. So that means any odd number, we can write any odd number as 2k, which is an even number, plus 1, where k can be any number. Okay? So let's look at an example. The number 5 can be written as 2 times 2 plus 1. The number 103 can be written as 2 times 51 plus 1. The number 1105 is an odd number because we know because the last digit is an odd digit. It's one of the 5 here. Therefore, it can be written in the form 2k plus 1. So that's 2 times 552 plus 1. And similar to the even case, we can write any odd number up to infinity as 2k plus 1. So here are some questions, exercise questions for you to try. Have a go at them and see how you get on. Integers. Integers is another term that we need to familiarize ourselves. So integers is a term that appears a lot within mathematics. So what is an integer? An integer is a whole number. Okay, so an integer can be positive or negative. All numbers that are integers are represented by the symbol capital Z with two lines in the middle. Okay, so for example, the number 2 is an integer, minus 4 is an integer, 100 is an integer, minus 246 is an integer. Okay, they are all whole numbers. Then we have natural numbers. So natural numbers are positive whole numbers, so not including 0. So all numbers that are natural are represented by the symbol capital N with two lines in it. So for example, you have the numbers 1, 2, 3, 204, all the way to infinity. They are positive whole, these are all natural numbers. Okay. Then we have rational numbers. Rational numbers are whole numbers and fractions. So they can be positive or negative. They are also repeating, and so they also include recurring decimals as well. Okay, so all numbers that are rational are represented by the symbol Q. For example, we have a third. So this is a fraction, but its decimal equivalence is 0.33333 for continuous. Okay, so it goes on forever. Then we have minus a half, which is in decimal, it will be minus 0.5. We have minus 99. We also have 10 over 2. So these are all rational numbers. Notice we have whole numbers. We also have fractions. Okay. Then we have irrational numbers. So irrational numbers are numbers that are not rational. So they cannot be integers or fractions. They are non-repeating and never ending. Okay, so for example, there's another terminology that you will learn as we progress through the course. It's called surds. So surds are irrational numbers. So for example, square root of 2. So if you were to put this into your calculator, square root of 2, you'll notice you get a really, really long number. But of those numbers, they will never repeat themselves. Okay, they'll just go on to infinity. Same with pi, and same as well, not the imaginary I, but it still counts as an irrational number. We have e, the letter natural, the exponential e. If you were to put it into calculators, you'll get a really long number. Okay, so these are irrational numbers. Then we have real numbers. Real numbers are all numbers including integers, fractions, decimals, rational and irrational numbers. So all real numbers are represented by the symbol capital R. Okay. So for example, we have 0.2 minus 3 half 24. Notice we have different types of numbers here. So these are all real numbers. There's another type of number that You could know. There's no harm in knowing, but you won't need it for GCSEs. But just for the sake of completion, it's called complex numbers. So complex numbers are all numbers that are imaginary. Okay, so complex numbers are represented by the symbol capital C. Okay, so they look like, for example, they have an I attached to them. So 3i minus I, but complex numbers will not be covered in this course. Okay, but if you go on to study further mathematics or A-level mathematics, you'll definitely see complex numbers. Then we have square numbers. So square numbers, or a square number, is any number that is multiplied by itself once. So, for example, we have 1 times 1 equals 1 squared. 2 times 2 is equal to 2 squared. 10 times 10 is equal to 10 squared. Okay, so these are square numbers. Any number that is multiplied by itself once. And they have to denote square numbers, we have that little 2 as the superscript. Okay, so we have the 2 as a power next to the number that is a square. Okay, to signify that it is a square number. So it is a good idea to memorize all the square numbers up to 12. The reason is that it will save you precious time in your examinations. So for example, you have 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, so on and so forth, all the way up to 12. Okay, it will really save you a lot of time during your exams. Okay, then we have the opposite of square numbers, which is square root of a number. So for square numbers, we were squaring, in other words, we were multiplying the number by itself. Now for square root of a number, we have a symbol. So this is known as a square root symbol. Okay, so the square root symbol, and underneath the square root symbol has the number that we need to find the square root of. So basically, to interpret it, we would say what two numbers multiplied together, or what number multiplied by itself equals this number underneath this symbol. So we know square root of 100, so we know that 10 times 10 is equal to 100, right? So square root of 100 is equal to 10. We also have square root of 81. So we can think like, okay, what two numbers multiply, or what number multiplied by itself gives us 81? If you know your timetables, you know that 9 times 9 is equal to 81. Okay. Now, one thing to keep in mind, you cannot take a square root of a negative number. Okay, not at this stage anyway. That's where complex numbers come in. But for GCSE, just remember that you cannot take the square root of a negative number. Another important note to keep in mind is that when you get two answers, when you take the square root of a number, you always get two answers, a positive and a negative. Okay, so the reason is because notice here, square root of 100 is equal to 10, because 10 times 10 equals 100. Now square root of 100 is also equal to minus 10, because if we do minus 10 times minus 10, that also gives us 100. Now the positive number is known as the principal root. So whenever you take a square root of a number and you're not asked for all the solution, you will only state the principal root, okay, which is the positive of the two. Then we have cube numbers. So a cube number is a number that is multiplied by itself 3 times. So for example, you have 3 times 3 times 3. We could write it as 3 to the power of 3 is equal to 27. So notice the number that has been cubed is being multiplied by itself 3 times, and that is signified by this small number 3 above this above the number that's been multiplied. Okay, so all cube numbers, they will have a little 3 on the top to signify that this number is being cubed. It is also a good idea to memorize at least the first 5 cube numbers. Again, for the same reason, it will save you time during examinations. Okay, not just at the GCSE level, also at advanced level. Okay, so you have 1 cubed is equal to 1, 2 cubed is equal to 8, 3 cubed is equal to 27, 4 cubed is equal to 64, and 5 cubed is equal to 125. Then we have the opposite of a cube number, which is the cube root of a number. Okay, so cube root, the way you would interpret it would be like, cube root, the symbol for a cube root is that it has a square root symbol, but the way we know that this is not a square root is because it has the little 3 next to it. Okay, so it will never be a big 3, okay, because if there's a big 3 next to it, that means it's 3 times. Okay, so whenever you're taking the cube root, make sure it's always a little 3. Okay, because what that means is that, or what's that, the way you interpret it is that what number multiplied by itself 3 times is equal to the number underneath this symbol, which is 1, 2, 5. And we know from here that the number 5, if you multiply it by itself 3 times, equals 125. Similarly, this number here, the cube root of 512 is equal to 8, because if you multiply 8 by itself 3 times, so 8 times 8 times 8, the answer will be 512. So you only get one answer when you cube root a number. So for example, whereas, before we've seen that we can't take the negative of a number underneath the square root, but this is not true for the cube root. When you cube root a number, okay? Because, for example, here you have cube root of 125 is equal to 5, because 5 times 5 times 5 is equal to 125. Okay, the answer is only 1. There's only one number, 5. Okay, whereas if this was cube root of 100 minus 125, the only answer is minus 5, because you get minus 5 times minus 5 times minus 5, which is equal to minus 125. Okay, so whereas for the square roots, for the square root symbol, we had 2 numbers, right? We had one positive, one negative. This is not the case for a cube root. Okay, you only get one answer. So here are some questions for you to try. So have a go at them and see how you get on. Now we move on to one of the most important aspects of mathematics, and that is familiarizing ourselves with the term BODMAS. Now, BODMAS is an acronym used for the most common mathematical operators. The order of operations or precedence is crucial to adhere to at all times when carrying out manipulations. Now, this terminology, BODMAS, there are other variations. So in some textbooks, it is referred to as BIDMAS. Okay, so instead of the O, there is an I, and in some other parts of the world, instead of using BODMAS, they use something called PEMDAS. Okay, but we will work with BODMAS. Okay, so what do each of these letters mean? So for BODMAS, the letter B stands for brackets. The letter O stands for order or power. The letter D stands for division. The letter M stands for multiplication. A stands for addition. And S stands for subtraction. Okay, so what this says is that anytime we have a problem, a mathematical problem, or anytime we're dealing with numbers in general, this is the order that we must always respect. We must always look for brackets first and work with that. If there are no brackets, then we move on to the order. Are there any powers? If there are no powers, then we move on to are there any division? If there's no division, then we move on to search for multiplication. If there are no multiplications, then we search for addition. If there are no additions involved in the calculation, then we move on to subtraction. Okay? And one thing I should mention, when we say mathematical operators, what that means is just the symbols for addition, subtraction, multiplication, division, okay? Brackets, order. Okay, the operators. These operators are just the formal name for those symbols. Okay. Now let's look at an example where we apply BODMAS. Okay. So we have this example here, example 1.103. Simplify the square root of 3 times 31 plus 3 squared minus 8 over 4. Now, following BODMAS, we look for brackets. Are there any brackets in this calculation? There are indeed. So we need to work within the brackets first. Okay. Then next, once we're inside the bracket, what are we looking for? We're going down the list. Are there any more brackets? There aren't. If there was another bracket, then we would focus on that bracket. Okay. So we do one step at a time. So once we are within this bracket, the next step is order. Are there any powers involved? Yes, there are. There is one term that involves power. That is this 3 squared. So we must focus on this term here. So that's 3 squared. 3 squared equals 9. Okay. Now we look through and we go through BODMAS again. We say, okay, so we've dealt with the brackets, we dealt with the order. Okay, are there any divisions involved? So we see, yes, there is a division involved here. So let's focus on that. So at this step, we do 8 divided by 4, leave everything else as it is. Okay. Once we do that, then we go through BODMAS again. So we've done brackets, we've done order. At this stage, we've done division. There's no more division. Next is multiplication. Are there any multiplications here? Oh, there is. 3 times 31. So let's focus on that. I will leave everything else as they are. And we just focus on 3 times 31. So 3 times 31 is 93. Now at this stage, we go through BODMAS again. Are there any brackets? Yes. There's no order. There's no division. There's no multiplication. Are there any addition? Yes, there is addition here. 93 plus 9. So let's do the addition. 93 plus 9 equals 102. And then we have, what we have is a typo here. That's better. So we have 102 minus 2. Okay, so we've done the addition. Now when we go through BODMAS again, there are no brackets at this stage because we're already inside the bracket. There's no order, there's no division, there's no multiplication, there's no addition, but there is subtraction. So 102 minus 2, which equals 100. Now notice that the 100 at this stage, we are still within the bracket. So the next step is, okay, we have a bracket and then we have an order. So the square root can also be written as the power of a half. So we're going to do square root of square root of 100 is equal to 10. Okay, so we did the bracket and order at the power. Therefore, notice that this entire complex looking calculation following BODMAS, each step of the way can be simplified to the number 10. Okay, so approach all problems from now on going forward using BODMAS. Okay, always follow these rules. Okay, never stray from it. Otherwise, the calculations will not be correct. You could try it out. Maybe try doing the multiplication before you do the division. Try doing the subtraction before you do the addition. You'll see that you'll get a completely different answer. It will be the incorrect answer. Okay, so it is very important to adhere to BODMAS at all times. So here are some questions for you to try. So have a go at them, following BODMAS, apply BODMAS, and see how you get on.